13 of them were first author papers, solo author papers. One of them was written with a senior PhD student, and another was written with Heitler, the famous Bhabha Heitler theory of cosmic rays shower. The first paper was in German, it was communicated by Pauli, and the third paper was communicated by Enrico Fermi when he was visiting Enrico Fermi. His PhD thesis was on the theory of scattering of positrons by electrons using the Dirac's formalism of relativistic quantum mechanics. It is this is the famous Bhabha scattering, which was cited for his Nobel Prize nomination in 1950s. This theory has stood the test of time. It was valid in 1930s, and it also remains valid even today. All the big accelerators in the world use Bhabha scattering to calibrate these things. So, then Bhabha also had another very important contribution from the theoretical consideration. He said that the penetrating component of the cosmic rays do not contain the usual electrons, but they comprise electrons which have several hundred times the mass of the electrons. This is essentially the start of heavy electrons and the muons and the pions from the theoretical consideration. And Bhabha also during his Cambridge stay sort of proposed the idea that when the pions decay spontaneously while they are moving at relativistic velocities, then the Einstein's theory of relativity comes into play, and so the Einstein's theory of relativity can be experimentally tested via a simple notion propagated by Bhabha. So, these are the schematics which was again sketched by Bhabha, which pertains the three components of the cosmic ray: the nucleonic component of the cosmic ray, the shower component of the cosmic ray. So, for the nucleonic component, you have to fly the counters way up into the sky, either using balloons or aeroplanes or the satellites later on. To observe the muonic component of the cosmic rays, you have to go deep underground. These are the experiments that Bhabha set it up in the Kolar gold fields several kilometers inside the surface of the earth, and the electron positron shower can be observed on the surface of the earth, for which Bhabha had the experiment set up at Ooty in the Nilgiri hills in South India. So, once Bhabha started this experimental work, Bhabha was the theorist behind his own experiments. So, this is the verification of the Bhabha scattering during Bhabha's time, and this is the verification of the Bhabha scattering in 1950s, even the present day time. This is extracted from the Venkatraman's book written in 1994. So, what did Bhabha do in Bangalore? He continued his theoretical work with full stream. In a period of next 5 years, he wrote another 17 papers. Okay. And earlier the papers were communicated by people like Dirac, but now or by his supervisor R. H. Fowler. Dirac and Bhabha had the same supervisor, R. H. Fowler. R. H. Fowler incidentally was also the supervisor for S. Chandrasekhar, the nephew of C. V. Raman, who did his PhD 2 years before Bhabha. D. S. Kothari, the famous D. S. Kothari, was sent by Meghnad Saha also to work with Fowler, and Kothari had also completed his PhD with Fowler 2 years before Bhabha completed his PhD. So, this is Bhabha's connection with the future people with whom he will collaborate as the India would become independent. So, most of the papers in the first phase in Bangalore were also written by Bhabha alone. Of course, he had few co-authors in few of the papers. There were few theorists who came from Calcutta. Saha sent those people to work with Bhabha this thing. And it is during Bangalore period only the Bhabha Heitler theory, whatever little gaps were there, Bhabha managed to give a complete form of the Bhabha scattering, collaborating with with Dr. S. K. Chakravarti after he got his FRS. So, now the experimental phase of Bhabha, once he comes to Bombay in 1945, So, these are the next set of 17 papers that he wrote at Bhabha. Several of them are experimental papers which we published with several co-workers from Bangalore and then again in Bombay. There is an important paper that Bhabha wrote in 1945. This was an invited paper written for the reviews of modern physics on the occasion of 60th birthday of Niels Bohr. And in this paper, the name of the Tata Institute of Fundamental Research is Tata Institute of Fundamental Research in Physics. So, initially when Bhabha proposes the establishment of the new institute, he wanted initially an institute for physics, but later on this institute becomes an institute for all branches of physics, mathematics, fundamental sciences, biology, etc., etc. TIFR had commenced at Bangalore in June of 1945, and I will give you a background of it as we proceed along. So, this is the last phase of Bhabha's papers, again written from Bombay, and this also has papers which are based on the lectures he delivered in Calcutta, also in the University of British Columbia in Canada. And so, in 1954 is the time when he wrote his last paper, and after that he wrote one more paper, and that was a kind of a conference summary of a conference that he attended in 1955, and it is during this in this conference that he identified M. G. Menon as his successor. So, Bhabha became aware of the aspiration of his peers in India during 1943, when he had started the work on experimental science along with doing the theory. What happened was that Saha had motivated his contemporary J.C. Ghosh, who was the then director of Indian Institute of Science and the president of a National Institute of Sciences, which transformed into INSA later on, to convene a meeting of all Indian scientists under the aegis of a National Institute of Sciences to discuss post-war organization of scientific research in India. So, all the teacher scientists of India got collected in Calcutta for 2 days to discuss how the science in India ought to be organized after the war would end. So, it is during that time Bhabha came to know all his peers were thinking of establishing newer institutes and newer areas of research as the India after the war. So, he also had his own thoughts to create an institute for fundamental sciences in India of a kind which did not exist at that time. So, this is how in August of 1943, you remember that Mr. Tata said 1943 Bhabha appears on the scene. In August of 1943, Bhabha writes his first communication to Mr. Tata proposing the establishment of Tata Institute of Fundamental Research. A month later, Bhabha contributes a paper titled Allocation of Scientific Research to Universities of India to this symposium. Proceedings of this symposium are published in the Proceedings of National Institute of Sciences, and now the proceedings are out. The Indian scientists wanted the British government to take cognizance of the plans they have drawn out for the plans of doing scientific research in India. By that time, the colonial government had become alive to the potential of the Indian scientists. After the start of the war, the colonial government got established a Council of Scientific and Industrial Research in India via Shantri Swarup Bhatnagar, who was a professor at Lahore. Bhatnagar had been moved from Lahore to Calcutta to create the Board of Scientific and Industrial Research first, which became CSIR in the September of 1942. So, now Bhabha comes in contact with Bhatnagar, and from now onwards Bhatnagar becomes the biggest supporter of Bhabha. Bhabha had become FRS in 42, Krishnan had become Bhabha had become FRS in 41, Krishnan had become FRS in 40, Bhatnagar became FRS in 43, and the secretary of the Royal Society brought those papers for all these people to sign. It is at that stage Saha via Bhatnagar made contacts with A.V. Hill, and A.V. Hill was now made to listen to the Indian scientist as he arrived in India to evaluate the plans for the organization of scientific research in the post-war India. So, Bhabha of course had known A.V. Hill during the Cambridge time, because Bhabha's own supervisor R.H. Fowler was a part of the Hill Brigade during the First World War, as they aided the war effort of the British during the First World War. So, Bhabha knew that government was only funding the research towards defense research towards the war effort through the CSIR. So, Bhabha tried to contact CSIR, and at the advice of one of his friends, namely Professor Choksi from the Wilson College, he sought some support from the CSIR for his newly conceived Tata Institute of Fundamental Research. Bhatnagar had proposed to establish National Physical Laboratory in Delhi. This was supposed to be a measurements lab, and Bhabha sought 10% of the money that Bhatnagar wanted to spend on NPL for his TIFR to take care of the fundamental science research agenda of India. So, with all this background, Bhabha prepared a proposal with the financial part of the proposal with the help of Professor Choksi, and on 12th of March 1944, he moved this proposal to the chairman of the Dorabji Tata Trust, and in this proposal, Mr. Nobel laureate A.V. Hill's name figures 4 times, because Bhabha had deeply consulted him. A.V. Hill was a Nobel laureate, he was a member of parliament from Cambridge, and he was also the advisor to the British government on all the war efforts. He had advised during the First World and also during the Second World War. So, A.V. Hill spent 4 months in India, and before he left India, he informed Bhabha of Saha's plan. Saha had conceived of Institute of Nuclear Physics at Calcutta, and Saha wanted to get Chandrasekhar back from America for his Institute of Nuclear Physics in Calcutta, but A.V. Hill wanted Chandrasekhar to come to Bhabha's institute. So, Hill revealed that plan to Bhabha. So, before Saha's letter could reach Chandrasekhar, Bhabha had invited Chandrasekhar to join him in the proposed new institute, and he offered him the same salary as he would receive himself as a head of that institute. So, this is a photograph of Bhabha flying balloons, and in this photograph you can see Dr. A.S. Rao. A.S. Rao was a physicist turned electrical engineer at Stanford on a Tata scholarship. Bhabha got A.S. Rao into Bangalore even before TIFR had come into being. So, A.S. Rao becomes an instrumentation man of Bhabha as Bhabha would proceed on the agenda for Atmanirbharta for India. So, this is A.S. Rao with Bhabha, and A.S. Rao, as you would see, becomes the electronics man of India as the time would proceed. So, Dorabji Tata Trust approved TIFR in May of 1945. Initial budget was just 80,000 rupees. Out of that, 45,000 was to come from Tata Trust, and CSR was to contribute only 10,000 rupees. Bhabha needed people, so Bhabha invited Indologist Kosambi and Levy for mathematics. Levy at that time was working in Calcutta, and Bhabha also enticed H.J. Taylor, who was a cosmic ray physicist, was working in Wilson College, to become a part of the TIFR initiative. Levy and Kosambi Levy could join later, but he left soon after about a year or 2. So, Bhabha had to look for somebody else to initiate the mathematics for TIFR a few years later. So, to get Chandrasekhar, Bhabha needed money. So, Bhatnagar gave him 75,000 rupees to get Chandrasekhar from America to India, and also pay for additional salary of a director to Chandrasekhar. And because now the CSR became the biggest donor to TIFR, the Bhatnagar was, as a director CSR, joined the Council of Management of TIFR. So, for the first 10 years, all the funding of TIFR came from Bhatnagar's CSIR. So, this is Bhabha, and on the day of inauguration of TIFR in Bombay on 19th of December 1945. This happened in a portion of the Kenilworth bungalow, the same bungalow in which Bhabha was born. This bungalow was occupied by Bhabha's aunt Kuvarji Pandey at that time. So, move forward. 1946, Pandit Nehru becomes Vice President of the Executive Council of the Viceroy. So, in this capacity he was the de facto head of the interim government. So, Pandit Nehru inducted PMS Blackett as his advisor. Blackett had not yet received the Nobel Prize, but Blackett was an advisor to the British government during the war effort as well. And Bhabha had knew Blackett because it was cosmic ray showers were first observed by Blackett using a cloud chamber. So, Bhabha knew Blackett already, and Bhabha anyway knew A.V. Hill. So, Bhabha knew all the important people, and this is Bhabha and Blackett in Bombay, and along with Taylor, and this is Bhabha, Blackett and Shanti Swarup Bhatnagar again in Bombay. So, Chandrasekhar eventually does not arrive. He had visa problems. He wanted to come on a leave from Chicago, and Chicago had difficulties in giving him assurances that he will be able to get a visa back to come to US if the experiment in Bombay fails. So, he eventually does not arrive. But anyway, India gets independence in 1947, but before the India got independent, Bhatnagar in 1946, after the dropping of the bombs in Japan, had created an atomic research committee within CSIR, and Bhabha was made the chairman of that committee. India becomes independent 11 days after the Indian independence. Bhatnagar had persuaded Nehru to transform this committee into a board for research in atomic energy. CSIR also had come into being from a board to a council. So, the board of atomic energy is created within the CSIR within 11 days. So, once the board was there, 6 months later the Atomic Energy Act was passed by the was passed next year, and Atomic Energy Commission was constituted. A 3-member Atomic Energy Commission was constituted with Bhabha as the chairman, and other 2 members were Bhatnagar and K.S. Krishnan. All 3 of them were it was a secret commission sort of a secret commission at that time, with only 3 members, all 3 fellows of the Royal Society. So, this commission transformed into an independent department of atomic energy 6 years later, only in 1954, and only when the Department of Atomic Energy becomes an independent department does the Bhabha start to receive money directly from the Government of India. In the meanwhile, Bhabha had got the physics school going. He had got K. Chandrasekharan from Princeton to start building the School of Mathematics. Bhabha had inducted Raja Ramanna from England to start the nuclear physics. Bhabha had got Bernard Peters, from a Danish citizen from US, to look after the cosmic ray programs, because once Bhabha had his hands in too many things. So, lots of things were now going independently. Bhabha got M.G.K. Menon in 1955, when the cosmic ray research also expanded. So, this is Niels Bohr visiting Bombay in the early 1950s, and Bohr being introduced to Mr. Tata by Bhabha. So, fine. So, on January 1, when the foundation stone of TIFR was laid. So, this foundation stone of TIFR is laid 9 years after the TIFR starts functioning on 1st of June 1945 at Bangalore. So, on Homi Bhabha stated on January 54, he acknowledged Bhatnagar for getting him the site for the institute. But Bhatnagar had a friend, Baldev Singh, who was India's first defense minister. He had known him from Lahore. It is Bhatnagar's connection with the Baldev Singh which got Bhabha the land for the Bhabha's TIFR. Bhatnagar had got NCL and NPL built from certain contractors, though the TIFR building was architected by Helmut Barsch from Chicago, but the building was actually built by the same people who built the NCL in Pune and NPL in Delhi, and Bhabha acknowledged Bhatnagar for all this. So, this is the TIFR model, and you can see this is the model, Bhabha showing the model to Pandit Nehru, and Bhatnagar is in between, and this model is the reality 8 years later on January 15, 1962. So, fine, when the TIFR foundation stone was laid 2 days later, Nehru had also laid the foundation stone of atomic energy establishment. DAE as a separate department happened in August of 54, and as soon as the department was separate, Bhabha submitted the proposal of having India's first nuclear reactor. A.S. Rao was in charge of the control equipment for that reactor. All the mechanical parts were made in the TIFR workshop. The Apsara reactor became critical in 1956 at the Trombay site. So, it is serendipity that in 1954 itself the Union General Assembly decided to hold an international conference on peaceful uses of atomic energy. Bhabha was chosen as the chairperson of that conference, and this conference happened in 1955, and it was attended by leaders and representatives from all over the world. So, International Atomic Energy also happened in Vienna in 1955. Bhabha was associated with IAEA right from the very beginning, and it was Bhabha was going to Vienna when his plane crashed in 1966, same Vienna. So, during the Geneva Conference 1955, Bhabha met his old Cambridge friend Lewis, who had made a natural uranium heavy water reactor for the Canadian Atomic Energy Commission. Bhabha partnered with that to build the India's Canada-India research reactor at Trombay, and so he sent a team of persons from Bombay to train under at Canada, and the Canada work on Canada-India reactor started. Half of the fuel of the Canada-India reactor was to come from Canada, other half was to be produced in India, and for that Bhabha had already made the preparation 8 years in advance. Bhabha had inducted Dr. Brahm Prakash, who had done his PhD with Bhatnagar and Lahore once. He inducted it from Cambridge, stationed him in IISc Bangalore to prepare a team of metallurgists whom Bhabha transported to Trombay in 1956, and Brahm Prakash was given the task of producing first half of the fuel for the Canada-India reactor. So, this is Bhabha with a whole set of young people that he took to Geneva. This was, Bhabha's identifying young people, nurturing them, giving them an exposure to the international arena. So, he took such a big team. So, there is Bhabha here, you can see Setna here, you can see A.S. Rao here, all these people were there with him in Geneva. So, fine, what did Bhabha say in Geneva? He said uranium and thorium might provide energy resources adequate for at least next millennium. So, this is what Bhabha had declared in 1955, and he also said, I venture to predict that a method would be found for having cheap fusion energy as well. So, this thing is going on even today. So, fine, everything is set in motion, but to have this grand agenda been implemented, you need bright young people. So, Bhabha gave this conception of an atomic energy training school in 1958. Ramana was made in charge of the atomic energy training school, and his training school is the backbone of India's atomic energy and space energy program. Space energy program also grew out of the atomic energy after the passing away of Bhabha in 1966. Sarabhai took over as the Atomic Energy Commission, and the Bhabha Atomic Research, the Atomic Energy Establishment Trombay, which transformed to Bhabha Atomic Research Center, that was handed over to Setna. Setna had earlier been given the job of extracting plutonium from the spent fuel of Cyrus. So, because you needed plutonium for Bhabha's dream project of 3-stage nuclear program of having fast speeder reactors. So, you needed plutonium 239 to have fast neutrons which would convert thorium 232 into 233, and that 233 was to be used in the 3rd stage. So, see the deep planning of Bhabha. Setna had been inducted as early as 1949 into the atomic energy program. So, this is the Chinese delegation visiting Apsara in 1956, 57 or 58. Bhabha could not foresee what Chinese would do after their return home. In a matter of 6 years, China had exploded its first atomic bomb in October of 1964, 6 months after the death of Pandit Nehru. This is, you see, Pandit Nehru with Brahm Prakash and Bhabha. This is Brahm Prakash with Shastri and Bhabha. So, Brahm Prakash was the central guy, and it is the same Brahm Prakash who, after the death of Sarabhai, takes off the space program, and before Satish Dhawan joins Brahm Prakash. Okay. These two people then steer along with Yashpal, Satish Dhawan, Brahm Prakash. They all had the Lahore Pass. That is how they had great comradeship, and that is the reason behind the teen spirit of the space program of India. You can see this. This is Satish Dhawan, this is Brahm Prakash, this is Kalam. Kalam was inducted into the atomic energy while Bhabha was alive. So, fine. I told you about A.S. Rao and the electronics, okay, and see, Bhabha was behind electronics, but before the electronics, Bhabha was behind the space program as well. In 1961 itself, Bhabha had got Government of India constitute a space research and peaceful uses of outer space as a new domain within DAE. And a year later, he got Indian National Committee for Space Applications and Research, which was on the lines of COSPOR, which meeting which Sarabhai had suggested in this thing. So, Bhabha got Sarabhai into the Space Commission, he took over PRL also under the atomic energy, and Bhabha submitted a report on electronics, and he said that this industry should be planned and organized without continuing dependence on foreign assistance. This would have revolutionary impact in science, industry and society. This is Bhabha's. So, for space, he said the reason for going into the space research is that there are many areas which are likely to yield results of great practical importance in the near future. If we do not do so now, we will have to depend later on buying know-how from other countries. So, this is Atmanirbharta in the DNA of Bhabha right from the very beginning. Same is the case with Tata Memorial Hospital. Tata Memorial Hospital was in the memory of Bhabha's aunt, Mrs. Dorabji Tata. This hospital came up 10 years after the death of both his aunt and Dorabji Tata. This was established by Dorabji Tata Trust, but since the cancer research was taken up by the US Department of Energy, so Bhabha felt that this should also be brought under the atomic energy, and that is how this entire agenda of Tata Memorial Hospital and cancer research became a part of the Department of Atomic Energy. In 1963, Bhabha got inaugurated Tata Memorial Hospital as a center for radiation medicine in Bombay. And today, India's this cancer hospital spread all over the country is the biggest conglomerate of cancer care globally. So, Bhabha and the radio astronomy, 4 radio astronomers had written to Chairman AEC, UGC and CSR, but only Bhabha was the quick to respond. Bhabha invited all the 4 radio astronomers. One of them was Govind Swarup, who was a PSc student of Krishnan at Allahabad. He had joined Krishnan and NPL. Krishnan sent him to Australia to learn radio astronomy. He came back, went to US. So, Bhabha immediately recognized him. He had met him in Australia for a brief while. So, he was invited and he becomes the father of the radio astronomy program in India. So, similarly, A.V. Hill had advised Bhabha to take up biophysics. Bhabha waited for Obaid Siddiqui to be recommended by Szilard in 1962. Within a matter of few weeks, Bhabha had Siddiqui joined TIFR. There was no biology in TIFR at that time. He got a full floor constructed for him. So, in the physics department of TIFR, physics school of TIFR, Siddiq, he comes in. So, he was in the physics department. It is an interdisciplinary feat. Siddiqui had physicists, engineers, mathematicians, everyone working for the molecular biology today. So, if India has a large presence in biotechnology, beginnings of that also got made via Bhabha. So, this is Bhabha's Science Policy Resolution of 1958. What did he say? He says, ensure adequate supply within the country of research scientists of highest qualities. He says, so secure for the people of the country all the benefits that can accrue from the acquisition and application of scientific knowledge. So, Bhabha was nominated for the Nobel Prize 5 times by the French mathematician. Bhabha after all was a mathematician to start with. He was nominated. Nobel Prize is such, you have to be nominated every year. If you do not get it one year, you are not considered next year. So, you have to be nominated every year. So, he was nominated 5 times. He did not get it. In 1951, Hadamard had also nominated Pauling, but he got the prize in 54. Bhabha himself had nominated Cockcroft in 1951 for the physics prize, and Cockcroft got it, Bhabha did not get it. Felix Bloch, Bhabha nominated it in 52. Felix Bloch got it, Lamb got it in 55. Bhabha had known Felix Bloch. It is from Felix Bloch, Bhabha imported Dharmati to start the NMR program for India. We have all these NMR imaging all over the country. Beginnings of that is Dharmati coming to India and starting the high resolution NMR studied in TIFR, and this is why India has some presence in MRI imaging in India. These are as the Lakshman saw Bhabha. This is on the occasion of the first Geneva conference. Okay, this is Bhabha's atom in a bullock cart, and when the Chinese explode the bomb on October 16, and this is November of 64, and Shastri is the Prime Minister now, and this is a mirror being shown for this thing. So, fine, I am near to the end of my talk. So, Bhabha had known Mrs. Indira Gandhi from 1936 onwards. Bhabha sailed in a ship with Mrs. Gandhi and Nehru in 1936 to England. Mrs. Gandhi is chosen as to succeed Shastri as Shastri passes away suddenly on 12th of January. Mrs. Gandhi approaches Bhabha and he convinces Bhabha to leave Bombay and come to Delhi and take over the agenda for the development of India using science and technology. Bhabha gives his consent to her that he will come back from Vienna and join her cabinet as a cabinet minister. Bhabha talks to M.G.K. Menon to become director TIFR, to Setna to become Ramana to Setna to become director BRC, and Sarabhai to be chairman this thing. But that doesn't happen. Bhabha is no more, and this is why Mrs. Gandhi said India would long cherish his memory, for he was deeply involved in her destiny. He was deeply involved in her destiny till then, and he has been involved in her destiny thereafter. Who succeeds Bhabha? Sarabhai, who was a student working for his PhD at Cambridge, then was together with him at Bangalore. Then it is Setna, then Ramana. Down the line, Kalam becomes the first chairman, first principal scientific advisor to Vajpayee. He was inducted by Bhabha in TIFR in 1964. Next PSA is Chidambaram. Chidambaram did his PhD at IISc Bangalore in NMR. He inducts him in BRC, puts him to do neutron scattering using the Cyrus reactor. Chidambaram is the next PSA. He was involved in the first nuclear testing of 1974. Ramana was also involved, Chetna was also involved. Second testing, Chidambaram is involved. Who succeeds Chidambaram? K. Vijayaraghavan. K. Vijayaraghavan was a student with me at TIFR. He is a chemical engineer who joined Siddiqui's molecular biology, succeeds Siddiqui as a director of NCPS, becomes a DBT and DST secretary, and is a PSA. And who succeeds K. Vijayaraghavan? Ajay Sood, who joined BRC training school, 16th batch. Ajay incidentally is studied with me at Chandigarh, and this is where he is today. He is steering the agenda, and this 1943, the Indian scientists had passed a resolution that India should have a National Research Council. This National Research Council happens in the form of an Anusandhan National Research Foundation, ANRF Act, 80 years later in 2023. Who steers it? Ajay Sood. Okay, another product of Bhabha's training school legacy. Similarly, Bhabha's student was Yashpal. Yashpal steered UGC. Yashpal's student was Ramnath Kaushik. He built the Hanley telescope, Hanley Observatory, the international observatory that India has. And in this budget, there is a huge push given to the astronomy research, India's presence in the astronomy research, space research. So everything continues to be Bhabha's legacy.
Yes.
Thank you very much.
Yes,
Thank you.
that's
Thank you
true,
so much,
sir.
sir.
Thank you very much for such an enlightening discussion and talk. Sir, you talked about the Bhabha's legacy. Yes, it is evident that still the three-stage nuclear policy, nuclear energy policy. You mentioned right in the beginning that he was a cosmologist, basically.
He was a
Cosmic ray research and
no,
then
he was a mathematician. His
Okay.
degree is in mathematics.
mathematics. Yes,
He works in theoretical physics.
he works.
Dirac was a mathematician. Fowler was a
Yes,
mathematician.
Fowler was a mathematician. Yes, yes. So,
Chandrasekhar was a
mathematician. So with this, sir, there is a curiosity. Number one, that how he came into the nuclear energy. Number one. Number two, you mentioned the scientist's intervention.
Nuclear
the
energy emerges out of the cosmic ray research.
I see.
It is in the cosmic ray research the transmutation of elements is found.
I see. So
It is in the cosmic ray research from the transmutation of elements you have these slow moving neutrons, okay, which will be observed as a nuclear fission of heavier
different
elements.
heavier elements.
This is what Otto Hahn and Lisa Meitner finds.
Fine, sir.
So once this nuclear fission happens, they know that there is a release of nuclear energy. If you can tame this nuclear energy,
You can get
then you have
can
peaceful
get
uses of
applications.
nuclear energy.
Right.
Yes.
So this is how it is. Bhabha worked with elephant.
So
Okay.
India's destiny, of course, India's
Yeah.
destiny is still being guided by the
Same thing.
Bhabha's legacy.
Yes.
Yes, you mentioned many scientists and many
Yes.
persons. At the same time, sir, you said about Hill that he was having the equal intervention into the politics. Or
Yes,
he was a
A.V. Hill was a mathematician.
and then
He was advised to study biology after the First World War. He transforms from a mathematician to a physiologist.
The physiologist.
In a matter of 6 years, he wins the Nobel Prize in Physiology.
physiology.
He was an operations research man during the First World War. This is where Fowler and company worked for him with him to have a mathematical formula which will predict the trajectory of shells which will be dropped by the German bombers, and they have to target this anti-aircraft guns have to.
Anti-aircraft guns.
So this is here their simulations gave this path from where the bomb is coming. So he was a mathematician turned physiologist. Later on, he was he was the bridge between the UK science and the American science.
Yes.
And then he becomes a member of parliament, an independent member of parliament from Cambridge.
Yeah.
Meghnad Saha emulates A.V. Hill and contests the parliament election from Calcutta South, and he becomes a member of parliament, independent member of parliament in the first parliament, and that is when Nehru and Saha had a fallout. Saha and Nehru had friendship dating back to Saha's Allahabad days. It was Saha who was very close to Nehru, even before Bhabha comes in contact with Nehru in 1936.
Yes, that's but the question which I am receiving from my colleague is it's linked. See, this legacy of having politics with the scientists. See, the development of science have always been taken over by the society. That funding to which side? So this legacy has been there. You mentioned about Indira Gandhi and Bhabha's relation, and then
Agenda is conceived by the teacher scientists.
Yes.
Government of India is the controller of money. The scientists compete to have the money go to one institute or the other institute. So there in this zero sum game, there is a little bit of maneuvering by these scientists. Raman wanted nuclear physics in Bangalore, Saha wanted nuclear physics in Calcutta, and Bhabha wanted in Mumbai.
Yes.
So there is a little bit of a tussle, but you know,
But
Saha passes away in 1956, but Nagar passes away in 55, and now it is left to entirely to Bhabha to steer the plans drawn up by the teachers, scientists of India 2 years before the independence of India, how to take the research and how to take the education forward.
So
Do you realize that Kothari is in charge of the defense research of India
Yes.
from 1949 to
To
1961. And there is a bonhomie between Kothari and Bhabha. They are both students at the same place.
Yes.
Kothari is a student of Saha, but Saha is no more after February of 1956. So from the scientist side, there is no difference in perception how the science and technology agenda has to be taken forward. It is only there is limited amount of money, and how this money should be fractured into which domain, more into CSIR, more into atomic energy, more into agricultural research, more into the medical research.
And
Or
this-
it is just this.
it comes from the policies, perspectives from the government.
Yes.
Yes. So
It is the appreciation of the political leaders
Yeah.
as what they think is important from their point of view, from the political economy.
Right.
Sir, one last query. How do you see that India in next 30 years as far as nuclear energy program is
See,
concerned?
that agenda is already set.
That-
India is already on this path today, on this mission-oriented research.
Yes.
That's
The
right.
government feels that the institutions that the government supports, they should be spending part of the time in pursuing their passions and part of the time pursuing the country's needs. Every scientist must work in a dual mode. You keep yourself competitive in your profession
Yes.
while
sir.
contributing to the mission of the nation.
Absolutely.
Be A.V. Hill.
Yeah. And sir, I'm
Yes, sir.
amazed.
Everyone has to be an A.V. Hill.
Yes.
Absolutely.
Many hills, many Bhabhas are required. I am sure that by 2047, the program which has been
I mean, Ajay Sood himself
yes,
is a combination of two.
these two, yes. So
We can
I am
say-
Vijay was
sure that
also a
SMRs
combination of these two.
True.
SMRs will also take place in a big way in this country.
Yes.
Yes.
So this is the third stage of Bhabha's.
That-
Third stage is an entirely different. SMRs are small reactors are not.
No, small reactors.
Small reactors are not the third stage.
Second, linkage between second and the third stage.
Second, third, so that is an entirely different agenda. That is to have fast breeder reactors.
Reactors.
Use the fast neutrons to convert thorium 232 into 233. Fast breeder reactors are supposed to consume less fuel and produce more fuel.
more fuel
That is
output.
as called
Output.
breeder reactors.
That's right.
This is right.
So small reactor agenda is an entirely
All right.
different science.
Very nicely presented, sir.
Yeah. And I
we are-
think there's no need to ask that had Shri Bhabha been around today, things would have been different because his contributions are still active in India's destiny.
Maybe things would have happened a little faster.
Yeah.
They may, but because he was a very towering leader,
Wow, yes.
you know, he passed away when he was just 56.
Yeah.
Look at his contemporaries who
Absolutely.
lived up to the age of 90s.
A great
if
loss
Bhabha had
for the
lived
country,
another
yeah.
10 years,
But so, you know what, we're still mesmerized with what you have mentioned in the entire presentation of yours, and I'm sure his legacy would continue like this, and India will progress the way it is progressing, and also at a much faster rate. Now, sir, we really thank you for your presence, for your time and contribution to the session. Thank you so much, sir. And now, Dr. Gagan, very quickly, I would like to ask you, who's coming up next?
Next, thank you, Professor Grover.
Thank you.
Thanks, SPSTI. Thanks, Panjab University. Thanks, Panjab Engineering College for having an association with NCERT for this program. दोस्तों, सन 2025 क्वांटम वर्ल्ड के 100 साल थे. 1925 में क्वांटम साइंस शुरू हुआ. 100 साल हमने पिछले साल बनाए. उसी क्रम में मेरे साथ अगले शुक्रवार को 6 मार्च को मेरे साथ स्टूडियो में होंगे प्रोफेसर मनोज हरबोला, from Indian Institute of Technology, Kanpur, and he will be speaking about a journey, an ongoing journey through quantum mechanics, through quantum principles. So, he will be talking about how these quantum mechanics principles are a part of our everyday life today. So, looking forward meeting you again on 6th of March, Friday, next Friday here at the same channel, same on YouTube network. Thank you very much.
Thank you so much. Thank you so much, Dr. Gagan Gupta. And now, viewers, 124th edition of our webinar series, Listening to Learn, has come to a close, where we talked about Homi Bhabha's legacy as a student scientist, institution builder and promoter of self-reliance in India. With this, it's a wrap, and let me very quickly give you the update regarding their program schedule. So, in a short while from now, you'll be watching a session on inclusive classrooms at 12 p.m. On mathematics, and I would like to thank both our ISL interpreters, Ms. Anushka and Ms. Sonal, along with my entire team for making the session a success. Thank you so much. Namaskar.